All right, we got a quiz here, and rather than write everything out for the solutions, we'll make it speed up a little bit here. You guys have the questions, okay? First one here, find all the possible rational roots. Now, we did this one for your warm-up, so it should be very easy. In fact, I'll just flash up the answers, because of course, again, we did this one already here. PQ test, so all the possible rational roots. All the factors of, it was -3, plus minus 1, plus minus 3, all over plus minus 1 and 2. Okay, remember I told you guys not to leave it like that. I want to see all your possible rational roots. So you have positive -1, positive -1/2, positive -3, and positive -3/2. Okay, that's full credit for 1A. You could skip 1B. I just wanted you to find out all the solutions. The solutions, again, I'm just going to take from what we did in the warm-up, because again, this was just a repeat. The second part, I think it was B, but we found out that x equaled -1, x equaled 0, and x equaled 3/2. All right, that should have been a gimme for you guys. We did that one. All right, so number 2, given the zeros, right, I want you to put this in factored form. Okay, so number 2. Now remember, to get the zeros, we basically put them in factored form by putting an x minus in front of them. Okay, so we'll start with this one here. To get the -3, that one had to come from x plus 3. Okay, and to get the solution, or a 0 of 2, that came from x minus 2. Okay, now these right here, all right, remember like we did in the warm-up here, 4 plus I, this is a complex number, and all complex numbers have conjugate pairs when they're solutions. So 4 plus I and 4 minus I are going to be 2 zeros. And to put each of those into factored form, right, we put x minus in front of each of those. Okay, so as far as part A, what is factored form? That is what your factored form is going to look like. And then I ask to multiply it all together, put it in standard form. It should be a polynomial. There was your hint, right? A polynomial of the 4th degree. Okay, and of course your hint must be, that's how you get the conjugate pair. All right, when we multiply these together, okay, remember only the real parts are going to be kept. Anything with an imaginary is either going to cancel out and you don't really need it, or it's going to be I squared, and I squared is going to get multiplied by -1. Okay, so I'm going to kind of shorthand the multiplication here and only do what's necessary. So x times x, x squared, -4x. Anything with an I is going to cancel out. Anything with an I is going to cancel out. That's -4x. Negative is a positive 16. Anything with an I will cancel out. Anything with an I will cancel out. And then here you have negative, right? This is going to be -I squared. Okay, but we know I squared, right? I squared is -1. So a -I squared is a -1, which is actually going to be a +1. Okay, so these two multiplied together, that's going to give me x squared minus 8x plus 17. And then you got the other two that we're going to multiply in just a second. All right, this is kind of busy work, but at the same time, hey, it's a review for that. All right, so we're going to multiply all this together. How you want to do it is up to you. These two, because I can do it in my head, we'll go ahead and do this. X squared 3 minus 2 minus 6. Okay, all right, and then you're going to get one hairy multiplication problem when you multiply a trinomial by another trinomial. Okay, most of you guys do things with the box, so I'll continue to do so also in the box. And here we go. Hopefully I don't make any mistakes. X squared, x minus 6, x squared. All right, if you're waiting for it, just the answer, you can fast forward to the answer here. x4 plus x cubed minus 6x squared minus 8x cubed minus 8x squared plus 48x, 17x squared, 17x, 17 times 6 is 102, -102. Okay, collect like terms, your final polynomial, y equals. Okay, and again, when we do this box, these kind of line up nicely for you guys here. So we got x to the 4th, that's going to be minus 7x cubed. That's going to be minus 14 plus 17, that's 3. 1748, that's 65. And last but not least, minus 102. Okay, that's number 2, the simplest polynomial standard form that you get, and it's a 4th degree polynomial. All right, number 3 is we're going backwards. So we're going to take our graph and make sure you can get the 5th degree polynomial. Okay, remember ways to check the 5th degree polynomial. All your multiplicities should basically add up to 5. Okay, so let's see if I can do this problem right next door here. So if I look at all my zeros, okay, my zeros, -3, and you'll see that it crosses. So because it crosses, it's going to tell me it has an odd multiplicity. Okay, I'm going to assume it's going to be 1 right now because it's not that high of a degree. I have a 0. That one bounces. Remember, the bounce is an even one, so this one's going to have a multiplicity of 2. And of course, this is also a bounce at x equals 1. Okay, so that's the information that we have to start. And this matches well because we're going to have a 5th degree polynomial. Remember, our multiplicities got to add up to that. Okay, and it wants this in standard form. Okay, so take this, we're going to write this into factored form, and then we'll just multiply everything up. Remember, factored form is nothing more than everything coming from their factors. Where did we get x equals -3? Well, that had to come from x plus 3, multiplicity 1. Okay, x equals 0, remember that just comes from the single x, that has a multiplicity 2, so we'll square that. And then x equals 1 comes from x minus 1, that has a multiplicity of 2. Okay, so if it asked you for factored form, that'd be perfectly good. And I just asked that you put it in standard form. I gave you time to do this, so that's why. Okay, x minus 1 squared. That's x squared minus 2x plus 1. Then I'm going to multiply in the x plus 3, and then we'll take care of the x squared last. Okay, again, busy math right here. I'll do it a different way. You guys are just checking your answers here. 3 times everything is 3x squared minus 6x plus 3. X times everything, x cubed minus 2x squared plus x. So this one down here is going to now give me x cubed plus x squared minus 5x plus 3. And then, of course, the last part, multiply in the x squared, and you got a final answer of x to the 5th plus x to the 4th minus 5x cubed plus 3x squared. Okay, and all that came from the graph that we started with. That is the graph of this polynomial. All right, number 4, I'm asking you guys to just do division. Now, remember, this one here is just a linear term. So because it's a linear term, I could do either long division or synthetic division. All right, so we're just going to do synthetic. If you want to do long division, feel free to ask me privately about that. Okay, so x minus 2 is going to give me a 2 up here in that box. This is problem number 4. Okay, now, simple as the problem is, hopefully you caught, we need a placeholder here, right? I got x cubed, but I don't have an x squared. So here's 3x cubed. Here's my placeholder for x squared. That's going to give me 4 and -5. If you caught that, you're home free. Here we go. Drop the 3, synthetic division, multiply, add, multiply, add, multiply, add. 3 times 2, 6, add. 6 times 2, 12, add. 16 times 2, 32, add. 27. Okay, remember this is your remainder, constant x squared. So my final answer that I'm looking for, 3x squared plus 6x plus 16. Don't give me R27, right? I asked you to give me with a remainder form here. So this is going to be with the remainder of 27 over x minus 2. Okay. All right, last but not least, here we go. I want you to solve. Basically, find all the solutions. I don't need a graph. I don't need to see all the things in between, but of course, we'll show you everything how we got there. All right, nothing that can be factored out. I'm going to start with my PQ test. All right, I need all my factors of 39. All my factors of 39. It seems like a horrible number, but it's not too bad. 1, 3, and I think maybe 13 might be the only one. Of course, the 39. Okay, and then we're going to do my q, which is just 1. Okay, so even though I didn't ask you, all my possible rational roots are going to be positive negative 1, positive negative 3, positive negative 13, and positive negative 39. Okay, not that bad. All right, you got to test these to see what works. Please start testing with the smaller numbers 1 and negative 1 first. Okay, so here we go, testing a 1. And my original 1 here, synthetic division, 1, negative 6, 18. Okay, now just like I asked you guys in class, remember we're doing the synthetic division here. We're testing for no remainders. No remainders will tell me that they're factors and they divide evenly. All right, 1, 1, negative 5, negative 5, 13, 13, negative 1. Works out to a nice number, but not the number I'm looking for. Okay, so not the good one here. Let's try negative 1, negative 1, 1, negative 6, 18, negative 14, negative 39. Same thing. Here we go, synthetic division. 1, negative 1, negative 7, 7, 25. Negative 25, believe it or not, this looks good. Okay, happiness, 0. All right, you didn't see all that. Okay, so what we have here, it's important to kind of like remember or see where we are with every step here. So we've broken that down and we figured out one of our factors is going to be x plus 1, and what's left is going to be x cubed minus 7x squared plus 25x minus 39. Okay, now by no means is that done, right? This is what we have so far. Now, again, we still have to break this down or try to break that down because we don't know how to solve that any other way. Now, because I don't know how to factor that, I can run the same PQ, the same rational root test. And remember, when I'm running the rational root test, I have the exact same numbers. Okay, if these were possible factors at the start of the problem, then they're still the same possible factors any part of the problem, even in the middle. Okay, now we can have a repeat. Okay, I already know that 1 doesn't work. If 1 wasn't a factor earlier, 1's not going to be a factor later. Negative 1 did give me a factor. It could give me another factor. Okay, so just because negative 1's a nice number, I'm going to try negative 1 again. Okay, so, right, I could have negative 1 as a 0 and it has a multiplicity of 2. So here's what I'm trying to divide now. 1, negative 7, 25, and negative 39. Here we go. Try negative 1. 1, negative 8, positive 8, 33, not too negative, don't like that. Okay, so we try the other numbers that we possibly have. I'm going to go to 3 or negative 3. Okay, hopefully I don't have to try one of the big numbers here. So 3, negative 7, 25, negative 39. Again, looking for a remainder of 0. There we go. 1 times 3, add, multiply, add, multiply. Check that one out. Nice. Okay, so now we found that x minus 3 is also a factor, so let's rewrite what we have. We knew x plus 1 worked. Now we know x minus 3 worked. And what do I have resulting? Now we got only a trinomial, which I can probably factor here. X squared minus 4x plus 13. Okay, we're looking for the solutions. We're looking for all the x's, right? We know this one here is x equals negative 1. We know this one here is x equals 3. Can I factor that? Okay, if you understand what we're trying to do, right? That's just looking to factor. That is not factorable. There's not two things that multiply to get 13, add to get negative 4. Okay, so I still got to find the answers, but if I can't factor it, what do we have? We got the quadratic formula. Okay, and hopefully that's a nice review. So here we go, quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, b's are negative 4s, a is 1, c is 13. All right, simplify, here we go. 4 plus or minus root 16 minus 52. That's going to give me a negative square root. Negative square root is going to give me a negative I. Do not cancel these out. We're not done with the problem. Do not cancel those out. X equals 4 plus or minus square root of, what's that here? 36. Ooh, that comes out nice. Negative 36. Okay. And that's going to give me 4 plus or minus 6i over 2. Okay. Now remember, just like when we have a complex number here, it clearly has a real part and it has an imaginary part. So if you separate 4 halves as my real and 6 over 2i as my imaginary, now we can simplify. That is 2 plus or minus 3i. Okay, so that is x equals that. All right, the whole problem we were to solve, and there were 4 solutions, right, because this was a 4th degree polynomial. Okay, so 4 solutions are right here. Negative 1, 3, 2 plus or minus 3i. All right. If you have any questions, still ask me. Otherwise, hope you guys did well, and I'll see you guys in class.